Hello, everyone, and welcome to Code Connect. I'm Emma, a computer science bachelor student, currently knee-deep in my thesis about AI tool integration. And I am so excited about today's topic.
And I'm Alex, senior developer and Python enthusiast. Today, we're diving into something I'm genuinely passionate about, the Model Context Protocol Python SDK. It's basically the Swiss Army knife for working with large language models in Python. Emma, I hear you've just started experimenting with MCP.
Yes, I stumbled across it last month when I was struggling to connect different AI tools for my thesis project. I was like, writing this mess of custom adapters for each API, and then boom, I found MCP and suddenly everything clicked. It's like, you know how Flask gives you a standard way to build web apps? MCP does that, but for AI tools. I've just set up my first server, and I'm honestly blown away by how simple it was.
That's exactly what it's designed for. I remember the pre-MCP days of AI integration. Absolute chaos. Different formats, incompatible APIs, custom parsers everywhere. Laughs. The Python SDK implements this beautiful standardized protocol that lets your applications talk to any LLM the same way. One line with fast MCP, and you've got a server running. Plus, you can add tools, manage resources, handle authentication, all with clean Pythonic patterns. I've built several production systems with it now, and it's genuinely transformed how we approach AI integration.
So, Alex, I'm setting up this MCP server for my thesis, and I keep seeing references to client session everywhere. Is that like the way my code actually talks to the server? I'm a bit confused about how all the pieces fit together.
That's exactly right, Emma. Think of the client session as your personal interpreter. You know how when you travel to another country, sometimes you need someone who speaks both languages? The client session is like that. It translates between your Python code and the MCP server. You say, I want to use this tool in Python, and it handles all the complex communication back and forth.
Oh, that makes way more sense. So it's kind of like a request handler in Flask, but specifically for AI tools. How would I actually use one in my code? Do I need to set up a bunch of configuration first?
It's much simpler than you might think. Let me show you a quick example. You'd start by importing the client session class, then you can create a connection like this. Async with create tar connected on our server and client session server as client session. Then boom, you're connected. From there, you can start calling tools with just a single line, like result, await client session.call.tool calculator, A5, B3 craze. The beauty is, it handles all the messy connection details for you.
Wait, that's it? Just a few lines of code? But how do I know what tools are even available on the server? I mean, if I'm connecting to someone else's MCP server, I can't just guess what tools they provide, right?
Great question. That's one of my favorite features. You can actually ask the server what it offers using await client session.list for tools. It returns details about every available tool. Same goes for resources. Just call client session.list resources. I had a project last month where we connected to 3 different MCP servers, and this made it super easy to discover what each one could do without digging through documentation.
Oh, that's brilliant. So I could dynamically build my application based on whatever capabilities the server advertises. I'm thinking I could use this for my thesis project, connecting to different AI services, and then showing what each one can do in a unified interface. But what about error handling? What happens if the connection drops or something goes wrong with a tool call?
I love where your head's at with that thesis idea. For error handling, the client session has you covered there too. Since we're using async touch await patterns, you can use standard Python try.dart except blocks around your calls. The SDK defines specific exceptions like tool execution error or connection error that you can catch. In production systems I've built, we wrap critical calls with retry logic. Something like, for I in range 3, try result, await client session.call tool. You get the idea. The session also handles reconnection in many cases, which saved me countless headaches during a demo that had spotty internet.
So I finally got my fast MCP server up and running last night. It was actually way easier than I expected. But now I'm like, okay, it exists, but what can it actually do? It feels a bit like having a brand new smartphone with no apps installed yet.
That's a perfect analogy, Emma. Your fast MCP server is like the hardware, but now you need to give it some capabilities. This is where tool management comes in. Think of tools as specialized functions that your AI can call. They're basically the apps for your AI assistant. Want your AI to check the weather? There's a tool for that. Calculate something? Tool. Generate an image? You guessed it, tool.
Oh, so tools are just Python functions. Wait, that sounds almost too simple. Are they like regular functions that I define, or do they need some special MCP magic to work properly with the language models?
They're absolutely just Python functions with a bit of MCP decoration. Let me show you. Say we want to create a simple calculator service. You'd just do something like eapp.tool and then define a function defadd int b int. Int, with the logic, return a plus b. That's it. The decorator registers your function with the tool manager behind the scenes, making it available to any AI that connects to your server. It's literally that simple.
I noticed you included those type hints. A, int, B, int, and int. Are those just for documentation, or do they actually do something in MCP? In regular Python, they're mostly optional, right?
Great catch. In MCP, those type hints are super important. The tool manager uses them to automatically validate inputs before your function ever runs. If a client tries to call your AD tool with A5 instead of A5, the tool manager catches that and returns a helpful error rather than crashing your function. It's like having a bouncer that checks IDs before letting inputs into your tool. You can even set default values like times, intiamandro1 for optional parameters.
That's actually really cool. So I can focus on writing the actual functionality without worrying about validation boilerplate. What about the output? Can tools return anything? Or are there specific formats I need to use for the AI to understand the results?
Tools are incredibly flexible with outputs. They can return basic types like strings, numbers, and booleans, but also complex structures like dictionaries and lists. MCP handles serializing everything properly before sending it back to the client. One thing I love doing is returning rich, structured data like user, name, Alex, role, developer, when appropriate. This gives the AI really clear, structured information to work with. Just remember that whatever you return should be JSON serializable, so no returning file handles or database connections.
So we've been talking about tool management in MCP, which I think I'm getting the hang of. They're like functions the AI can call, right? But now I'm hearing about resources. How's that different? Is this like going from actions to knowledge?
Great question. Yeah, think of it this way. Tools are verbs. They're what the AI can do. Resources are more like nouns. They're what the AI can reference or read. If your AI assistant is a researcher, tools are the actions they can take, while resources are like their reference library. It's basically how we provide context to the AI beyond just capabilities.
Oh, that makes sense. So if tools are like Python functions, resources would be like, what? Databases or documents. I'm trying to picture how I'd actually implement this in my thesis project. Would I need to create a whole new system for managing these resources?
Not at all. MCP makes this super easy with the Resource Manager. It's just as straightforward as adding tools. Look at this. app.add resource, facts chart greeting, hello world. Boom. Your AI now has access to that greeting text. You can add PDFs with app.add-filed portrait resource, database connections, you name it. Think of Resource Manager as your librarian, organizing everything, finding what's needed, and making sure it's all accessible when the AI comes looking.
Wait, so I could actually give my AI access to all my thesis research documents as resources? That would be incredible for my project. Are there different types of resources, or just static text and files? I'm wondering if they can be more, interactive.
You're on fire today, Emma. Yes, you absolutely could add your research docs, and resources get way more interesting than static content. You can create dynamic function resources that generate content on the fly. For example, check this out.
Oh, so you're decorating a function with app.resource, similar to how we did with tools. And it looks like this timestamp one would give different results each time it's accessed?
Exactly. And here's where it gets really cool. Resource templates. Let's say you want personalized content. You'd do something like app.resource.template, greetings, name, and define a function that takes that name parameter. When the AI requests greetings Emma, it gets hello Emma, dynamically generated. It's like having a fill-in-the-blank worksheet that creates custom content on demand. Super powerful for personalization.
So we've been talking about resource management in MCP, which is super helpful for getting my data into the system. But I'm wondering, once I have all these resources loaded, how do I actually structure the conversations with the AI? Like, how do I tell it exactly what I want it to do with my data?
That's exactly where prompt management comes in. Think of it this way. Resource management is about giving your AI system access to information, but prompt management is like writing the script for how the conversation should flow. It's the difference between having actors and props on a movie set versus actually having a screenplay for them to follow.
Oh, that makes sense. So resources are like the raw materials, and prompts are the instructions for using them. But wait, how do I actually create these scripts in MCP? Is it similar to how we defined resources with decorators?
Spot on. It follows the same elegant pattern. You create prompts using the OAup.prompt decorator. Let me show you a super simple example. Say you're building a greeting service. You'd write something like eapp.prompt, and then define a function called greeting that returns a string like, hello, how can I help you today? That's literally all it takes to create your first prompt.
That seems almost too easy. So it's basically just a function that returns a string. How is that different from just hard-coding the greeting somewhere? And what if I need something more dynamic than just a static greeting?
Great question. The power really shows when you start parameterizing your prompts. For example, you can create a template that accepts arguments like app.prompt, then def personalized, chart help, name, str, issue, str, that returns something like hi, my name is name, I need help with issue. Now your prompt is dynamic. You can also structure multi-turn conversations using user message and assistant message types to create entire conversation flows.
Wait, so I can actually define an entire conversation pattern. That's brilliant. It's kind of like creating a Flask route, but instead of handling HTTP requests, you're handling conversation flows. And what's really cool is I can pass variables into these templates. So in my thesis project, I could create templates for different AI analysis patterns and just swap in different parameters depending on the context.
You've got it. And that's why prompt management is so powerful. You're creating reusable conversation patterns. In production systems I've built, we maintain libraries of hundreds of prompts for different scenarios. And here's where it gets even cooler. From the client side, using these prompts is super straightforward. You just render the prompt with your parameters, and the SDK handles all the complicated stuff behind the scenes. It's like having conversation Lego blocks that you can assemble in different ways for different needs.
Hey Alex, I've been diving into prompt management for my thesis, but I'm hitting a wall with something. I built this simple tool that helps students find AI resources, but it feels, I don't know, too static. Like I want it to be able to ask follow-up questions if it needs more info. Right now, I'm handling that with these messy if-else chains, checking if the user input has enough detail. There's got to be a better way, right?
Oh, absolutely. You're actually hitting on something perfect. What you're looking for is MCP's elicitation framework. It's like the natural evolution after prompt management. Instead of trying to anticipate everything up front or writing tons of conditional logic, your tool can just ask for what it needs when it needs it.
Wait, so it's kind of like when you order food at a restaurant. And instead of making you fill out a comprehensive form of all possible preferences, the server just asks follow-up questions as needed. Like, how would you like that cooked? After you order a steak.
That's exactly right. Perfect analogy. The server doesn't bombard you with 20 questions when you first sit down. They ask contextually relevant questions exactly when needed. In MCP, we handle this with the elicit method. Let me show you a super simple example with a weather tool. You just need a pydantic model defining what info you need, like city and country, and then your tool can pause execution to ask for that data. The code is surprisingly elegant.
Oh, so I'd create a model like class location info with city and country fields, and then inside my tool function, I'd call something like ctx elicit with that schema. And it just pauses everything while waiting for the user response. That's so much cleaner than what I've been doing with callback functions and state tracking.
Exactly. The execution literally pauses at that point. It's all handled by the framework. And since you're using Pydantic, you get validation for free. If the user enters something that doesn't match your schema, MCP handles that automatically. But the real power comes when you start building chains of elicitations. Imagine a tool that first asks for location, then based on that response, elicits more specific information like indoor or outdoor activities, all while maintaining context.
Wait, I think I'm having a light bulb moment here. So for my thesis project, instead of trying to build this complex state machine for my recommendation tool, I could just define different schemas for different information needs and elicit them on demand. Like, first ask for the subject area, then elicit knowledge level, then preferred resource types.
You've got it. That's the exact pattern we see in production systems. And here's where it gets even cooler. You can nest elicitations within tools that are called by other tools. We built a system for a healthcare client where the main diagnostic tool would call specialized tools that would each elicit their own information sets. The whole interaction felt completely natural to the user, but behind the scenes, it was this elegant choreography of tools and elicitations. For your thesis, this approach will save you hundreds of lines of state management code.
So we've been talking about the elicitation framework and how tools can ask users for information during execution. But I'm wondering, once that information is requested, how does it actually travel between the client and server? Like, what's happening under the hood when I'm building my thesis project?
That's a great question. We're moving from what information gets exchanged to how it physically moves around. These are called transport mechanisms in MCP. It's like, you know what message you want to send to your friend, but now you need to decide, do you text them, email them, or mail a physical letter? Each method has different trade-offs.
Oh, so transport mechanisms are like the delivery services for our data. That makes sense. I'm building this server for my thesis using MCP, and I'm not sure which transport to use. What are my options? In Flask, I just set up routes, but I'm guessing this is different.
You've got three main options with MCP. There's SDO, super simple, just using standard input and output streams, perfect when your client and server are on the same machine. Then there's WebSockets for persistent connections, great for real-time stuff like chat apps, and HTTP streaming, which uses regular HTTP connections but keeps them open for continuous data flow. Each has its sweet spot depending on your use case.
I think WebSockets might work for my project, since I need real-time updates. But how complicated is it to implement? Like, show me the actual code. Is it a bunch of boilerplate, or?
It's surprisingly clean. Here's what connecting with WebSockets looks like. You do async with WebSocket client with your endpoint URL, then create a client session with those streams. Something like async with WebSocket client, example.com, MCP, as streams, async with client session streams as session. And then you're off to the races. The cool part is that your tool calling code looks identical regardless of transport.
Wait, so if I start developing with STDO for testing locally, I can switch to WebSockets later without rewriting all my business logic? That's actually brilliant. Most frameworks make you commit to your transport method up front.
Exactly. That's one of my favorite things about MCP's design. I worked on this project last year where we started with a CLI tool using stdio, but then requirements changed and suddenly we needed a web interface. Because of this transport abstraction, we literally just swapped the transport layer and kept all our tool code. Saved us weeks of work. It's like changing how you get to work without changing what you do at your job.
So I just got my MCP server running with those transport mechanisms you told me about last time, but now I'm worried about security. Right now, literally anyone can call my weather prediction tool if they know the endpoint. How do I make sure only authorized users can access it?
That's a great next step, Emma. You're right to be thinking about security. What you need is authentication and authorization, basically the digital equivalent of ID checks and access badges. Let me show you how easy it is to add that to your MCP server.
Wait, so authentication and authorization are two different things. I always thought they were basically the same.
Common confusion. Think of it like going to a concert. Authentication is showing your ID to prove you're the person who bought the ticket. I am who I say I am. Authorization is the ticket itself determining where you can go. Maybe you have general admission or a VIP pass. In MCP, we handle both with a pretty elegant system based on OAuth 2.1.
Oh, so authentication is about identity, and authorization is about permissions. That makes sense. So how do I actually implement this in my weather service? Is it complicated?
Not at all. Here's a simple example. You just need to add auth settings when creating your FastMCP server. Something like app, FastMCP name, secure weather service. Auth settings, auth settings, issuer, URL, https, auth.example.com. With that one change, your server now requires proper authentication tokens. Then users get access tokens with specific permissions, called scopes, that control what they can do.
Scopes? Oh, that sounds useful. So I could have a free tier with basic weather info, and then a premium tier with more detailed forecasts, all controlled by different scopes.
Absolutely. That's one of the most powerful features. You can define whatever scopes make sense for your service. For example, you might have red basic tart weather for free users and read premium weather for paying customers. In your code, you'd just check for the appropriate scope before returning the premium data. It's as simple as adding a decorator to your function, like requires tar scope, read premium tard weather.